Hello, Jessica. Sorry, I've had such a busy day today. I've tried to get a chance to do this for you, and this is the first chance I've had. So I'll just do it real quick. This is not a whole lot of work, this question. When you're calculating your F statistic, your F calc, then it's just the ratio of your variances. So you just have to take your first variance, the 2.84 over the second, which is 9.15. I think it's that way around, F1 over F2, X and Y, yeah, I think it's that. And then it's, this one works out to 0.3104. And then your degrees of freedom is just subtracting 1 from each of your data sets. And so you've got strain 1 and strain 2, there's 10 data points in each. And so when you go across your F chart, it's got degrees of freedom along the top and along the bottom, or along the side here. So you have to go down to 9 and along to 9 on the chart there for the 0.05 alpha. And I think that the value that you get from the chart is 3.1789 if I was looking at the correct chart. And just double check that, because like I said, I had to just do this in a real hurry today because I've had a busy, kind of crazy day. So when you're comparing your F statistics, this one compared to the F calc, then you would fail to reject there. In other words, you would conclude that the variances are equal. This is only worth 1 mark, so that's all there is to it. As long as it's in the, if it's not in the rejection region, then basically the variances are considered to be equal, even though I know the numbers aren't equal. The F statistic tells you that it's in the normal range, and that's what we're looking for. And so in the degrees of freedom question for the next part, where it says what is the number of degrees of freedom associated, okay, I didn't get a chance to do the t-test, work that out for you yet, sorry. The t-test, the degrees of freedom is the same. It's going to be 18, because you've got a total of 20 data points and you're going to subtract 1 from each group. So that gives you 18 for your degrees of freedom. And then to calculate your test statistic, you're going to go to the t-chart and you're going to look for alpha equals 0.05. It doesn't say if it's one-tailed or two-tailed, so I'm assuming that it's a one-tailed test then. And you're going to use degrees of freedom 18 like we said, and you're going to get your test statistic from your chart, and you're going to compare, your test crit from your chart, and compare that to your test statistic that was given at 5.12. And so if your T crit, I hope you can see that blue, if T crit, maybe I'll change that to a white, T crit is greater than T test, then you have to reject. If it's the other way around, you accept the null. So if your t-test is, if your t-test statistic, oh, I'm sorry, I did that backwards. If the t-crit is greater than the t-test, then what that's doing is putting it outside of the normal region. Here's your normal region. Your t-crit is here. Your t-test then would be smaller, which would put it in the normal region. So you would accept the null in that case. Okay? So I'll leave it to you to look up on your t-chart what your t-crit should be, and then when you compare it to the 5.112, you can make your decision on whether you would accept or reject the null based on what value you get. So I hope that's helpful, and I apologize again for it taking so long for me to get back to you today.